here what we have is, it says solve 6x cubed minus 13x squared plus x plus 2 equals 0. So solving this equation where the left side is a polynomial means we are trying to find the roots of that polynomial. You know, whether they're real roots or they are complex roots. Our job is to find the roots of this polynomial. In order to find the roots, if they are real and rational, then we should be able to, if we have real and rational roots, we should be able to factor this polynomial. All right?
Yeah.
So let's go ahead and call this polynomial f of x. We did that. So it's in descending powers of x. So we look at the constant, which is 2. The factors of 2 are plus or minus 1, plus or minus 2. Then we will take note of the factors of the leading coefficient if it's not a 1, which it is not. And so that's 1, 2, 3, and 6. Got it?
Yep.
Now, since we already said plus or minus for the factors of 2, that's why I didn't write plus or minus here. Now, in order to factor this, we have in order to apply the rational roots theorem here, we have to consider each factor of 2 over each factor of 6. Okay? So in other words, the values which we will look for, in other words, the values we will use for trial and error to see if this polynomial equals to 0 are each factor of the constant, including the negative ones, over the factors of the leading coefficient, over each factor of the leading coefficient. So we'll just say we're going to try plus or minus 1, plus or minus 1/2, plus or minus 1/3, plus or minus 1/6, plus or minus 2, plus or minus 2/3, plus or minus, that's it. Because 2/6 is the same as 1/3, which we already have there. Okay? So do you understand how we got these? So first, this plus or minus 1 over each of these, which means plus or minus 1 over 1, plus or minus 1, plus or minus 1 over 2, positive or negative 1 over 3, then plus or minus or positive negative 1/6, plus or minus 2 over 1, which is 2, but 2 over 2 was 1, which we already had considered, so that's why I didn't write down, and then 2/3, and then 2/6, which is just 1. Does that make sense? Do you understand? Hello? Are you there? Sitbit? All right, so let's continue now.
Yep.
So do you understand so far?
Yeah, I do.
Okay. So now, since we have so many values, it'd be foolish to just plug them all in. So let's narrow it down to see what our possible factors could be, right? So what I mean by that is, let's say I start with x equals 1. I see what happens at x equals 1. Well, if I plug in x equals to 1, what I have is f of 1 is equal to 6 times 1 cubed minus 13 times 1 squared plus 1 plus 2, right? F of 1, so I'm replacing every x with 1. Now, does that equal to 0? Well, no, it doesn't equal to 0. But let's be more specific in noting that it actually yield a negative value. So for example, 6 minus 13 is negative 7, plus 1 is negative 6, plus 2 is negative 4. That's a negative value. It does not equal to 0, but it is less than 0. Do you see?
Yeah.
However, we notice that if we were to substitute in, let's say, 0, we would get positive 2, right? The y-intercept of that polynomial function would be 2. So we see that f of 0 would give us 2, which is greater than 0, correct?
Yeah.
So then we know that polynomial functions are continuous. In other words, if you have from left to right, if at x equals to 0, you get 2, and at x equals to 1, would we say negative 4, then we know in a continuous function, left to right, the graph has to cross the x-axis somewhere between 0 and 1, right?
Yeah.
So, right, because this point was 0, 2, and this point is 1, 4, right? Now, perhaps my depiction of that could be a little bit better, but once again, this is the point 0, 2, and this is a point 1, negative 4. And we know it's a odd degree polynomial with a positive leading coefficient, so the graph would extend from quadrant 3 to quadrant 1. So if we were to just simulate that, that would probably go something like that, right?
Yeah.
Quadrant 3 down here to quadrant 1 up here. So that means this passes somewhere along there, right? So there has to be a root somewhere between 0 and 1. It doesn't have to be a rational root. It could still be irrational. We don't know, but we know that there has to be a root between 0 and 1. Well, we have plenty of values here that are between 0 and 1 to try, like positive 1/2, positive 1/3 is between 0 and 1, 1/6 is between 0 and 1, right? So
Yeah.
let's try one of those. Let's see. So let's try 1/2 now. And if we use 1/2, we get 6 times 1/2 cubed minus 13 times 1/2 squared, and then plus 1/2, and then plus 2. Agreed?
Yeah.
If we work that out, we have 6 times half cubed is 1/8. That's 13 times 1/2 squared is 1/4, plus 1/2 plus 2. 6/8 is the same as 3/4, minus 13 times 1/4 is 13 quarters. Plus 1/2, positive 1/2 is the same as positive 2/4. And plus 2, well, 2 is the same as 8/4, right?
Yeah.
So lowest common denominator is 4. If we add up the numerators, 3 minus 13, which is negative 10, plus 2, which is negative 8, plus 8. Well, there you go. It adds up to 0, and 0 divided by a non-zero value is equal to 0, right?
Yep.
So that means we found that f of 1/2 equals to 0. It didn't have to work out that nicely. It just did. Understand?
Yep.
And if that didn't work out, I would have tried 1/3. I would have tried 1/6 because they're also between 0 and 1. Okay? Fortunately, this worked out. So you see, you can narrow down your choices like that. Understand?
Yep.
When there are many. All right, so now that we know f of 1/2 equals 0, what would be my factor? Can you tell me?
It'd be x minus 1/2.
Well, if it was that easy, I wouldn't have asked that question, first of all.
Oh.
So technically not incorrect. However, we don't use a fraction in our factor. So we don't say x minus 1/2. Okay?
Mm-hmm.
Bad form. So we say that 2x minus 1 is a factor.
Oh, yeah.
Okay? So the idea is x equals to 1/2 led to the polynomial being 0. So you multiply both sides by 2 and you get 2x equals 1. You bring the 1 over, so you get 2x minus 1 equals 0. So this 2x minus 1 is the factor. Just like before, when we got, let's say, x equals to 1, and we said x minus 1 is a factor, well, because x equals 1 was the same thing as x minus 1 equals 0, so that's why x minus 1 was a factor. Or if it was x equals negative 1, then x plus 1 equals 0, so x plus 1 is a factor. Do you see the pattern?
Yep.
All right. However, here we have x equals half. Half is a fraction. I guess it wouldn't be wrong. Well, it wouldn't be, but a nice or the best form, for lack of better words, better form would be to avoid fractions. Understand?
Yep.
So we say 2x minus 1 is a factor. Any questions there?
Nope.
All right, so let me erase that. And now we can do long division or synthetic division. Since you're comfortable with long division, I'm going to show you synthetic division here. Because there's a trick to synthetic division. Well, let's do both ways. But first, let me do synthetic division. So when we do synthetic division, the quotient we obtain should be the same as the quotient we should obtain when we do long division. Does that make sense? Right?
Yeah. Yeah.
In this case, the divisor is linear, 2x minus 1, so we can do synthetic division. But if you notice in all the other cases, so far, all the examples you've done so far, it was when it was in mx plus b form linear, the m was only 1, but now the m is not 1, right?
Yeah.
So does that affect how we do synthetic division? Well, it doesn't affect how we perform synthetic division. What it does do is affect the quotient, meaning we won't probably get the same quotient as we would do in long division unless we alter something, unless we make an altercation, or unless we make an alteration is what I meant. Understand?
Yeah.
So let's take a look at synthetic division here. So it works the same way. Set it up the same way. So we have our box. Right? Our polynomial was 6x cubed minus 13x squared plus x plus 2. It's descending powers of x. The powers of x are descending by 1. So it's 6, negative 13, 1, and 2. The coefficients, right? Now the value of x which made that polynomial equal to 0 is still 1/2. So we write 1/2 there. Understand?
Yeah.
And so remember, we dropped that first value from the box below, so 6. Now we take that 6 multiplied by that value outside the box, which is at the top left, half. 6 times half is 3. So we have 3. Now remember, we add the columns, unlike in long division where we subtract. So negative 13 plus 3 plus negative 13 plus positive 3 is negative 10. And then negative 10 times that half is negative 5. And then 1 plus negative 5 is negative 4. And then negative 4 times half is negative 2. And 2 plus negative 2 is 0. That sum of that last column is your remainder. Remember?
Yep.
As it should be, because we claimed x, 2x minus 1 is a factor. So the remainder is 0. And remember, this gives us our quotient, right? And since we started with a third degree polynomial and divided by a linear first degree, 3 minus 1 is 2. So we have our quotient to be quadratic again. And ax squared plus bx plus c, where a is 6, b is negative 10, and c is negative 4. So what we have is 6x squared minus 10x minus 4, right?
Yep.
But here's the thing. If we were to do long division right now, would we get that exact quotient? The answer is no. So even before we get to that long division, here's how it works. So when we do the long division, the quotient that we will get when we do it, you'll see, is the quotient we will get is actually 3x squared minus 5x minus 2. Why? Well, it has nothing to do with always just taking half. It has to do with whatever this denominator is. So in synthetic division, if this number outside is a fraction, whether it's a positive fraction or a negative fraction, it doesn't matter. It also doesn't matter what the numerator is, whether it's a 1 or a million. The only thing that matters is the denominator. Doesn't matter the sign, negative or positive fraction. It doesn't matter the numerator. The only thing that matters is the denominator. So the idea is, without getting too much into it, the idea is that 2 right there, you have to divide each term of the quotient by that denominator. So my quotient is not just 6x squared minus 10x minus 4, but rather 6x squared divided by 2, negative 10x divided by 2, and negative 4 divided by 2. So my final quotient is going to be 3x squared minus 5x minus 4. All right? Any questions so far?
So well, this is on the synthetic division. So if just say the what's it called, the quotient, if it's like would you write it? Oh, how do I explain this? But can you write the quotient as like a fraction or like a decimal?
What do you mean?
Yeah. See. So you know, or where's my pointer?
What?
I'm gonna try pointing it. So, like, just say if this -10 was like it
A
was like
3? An
or like
odd
if it was
number?
like, no, if it was like a fraction or if it was like a decimal, how would I write it in like this?
You always write it, just leave it as a quotient, as a fraction.
Oh, okay.
Can use decimals if they're exact, but just leave it as a quotient. But you're not going to get a question like that, rarely. Okay? Rarely. All right, well, let me continue. So you'll see now that we do long division, you'll see what quotient we get. It's possible you can get a fraction in your answer. It's possible, but it's very rare. I've rarely seen it. Okay?
Okay.
So we'll worry about that when we get to it. Okay, so for right now, let's worry about what we have in front of us. So we have 6x cubed minus 13x squared plus x plus 2, and we're dividing by, now here, you're dividing by 2x minus 1. So 6x cubed divided by 2x, you know how this works. I'm just going to do it quickly now. 6x cubed divided by that 2x is 3x squared. I'm going to use blue. 3x squared. And then that 3x squared times the 2x here is 6x cubed, and 3x squared times -1 is negative 3x squared. When we subtract, negative 13x squared minus negative 3x squared is negative 10x squared. Right? If you disagree with anything, let me know. Then we carry down the plus x. We only have a couple of minutes left, so I have to go quickly. Now negative 10x squared divided by 2x is negative 5x. So negative 5x times 2x is negative 10x squared, and negative 5x times -1 is positive 5x. Right? Stop me if there's something I'm saying that you don't understand, even though we've gone over this before.
Mm-hmm.
Now, when you subtract, x minus 5x is negative 4x. Another thing I should mention, an example we haven't come across. Now you notice when you subtract, this first difference is always 0, right? Correct?
Yep.
But so we don't write it. However, if there are any other differences that are 0 after that first one, for example, I suppose this minus this was also 0, the x terms, you would write 0x. I do want you to write that down. Understand?
Yep.
It's only the first one we ignore. So now that's negative 4x, and we carry down the positive 2. Now repeat, negative 4x divided by 2x is negative 2x, right?
Yep.
I had to plug in my device because the battery was low. So that's negative 4x. So now, lost track there. Now we take that negative 2x multiplied by each term with the divisor. So that's going to give us negative 4x and then plus 2x. And why did I write 2x? I meant just 2 in the quotient there. Got distracted with the low battery. It's not an excuse though. But we caught it. It's negative 2 there, right?
Yep.
So negative 2 times 2x is negative 4x, and negative 2 times negative 1, positive 2. And you see the remainder is 0, right?
Yep.
But more importantly, do you see what the quotient turned out to be? Do you see that?
Yep.
It's 3x squared minus 5x minus 2. So that, therefore, had we left this as 6x squared minus 10x minus 4, that would have been incorrect. Do you see?
Yep.
Because when you divide by 2x minus 1, that's the quotient you get. Is that clear?
Yep.
Okay. So you have to remember that when doing synthetic division, if this is a fraction, because in synthetic division, you can't use the 2x minus 1, you have to use that as a fraction. So this is a fraction. Whatever quotient it is, you have to divide each term by that denominator. Understand?
Yep.
Doesn't matter if it's negative or positive, you ignore that. And doesn't matter what the numerator is. The numerator could have been 3 over 2. It doesn't matter. It's just whatever is in the denominator, you divide each term of the quotient by. Got it?